Welcome, geometry students, to the homework help video, page 180. Let's go ahead and get started with the following problems. Okay, number 9. The directions say to name the included angle of the triangle. Okay, so very quickly, we have triangle JKL, JKL, and they want to know what is the included angle of JK and KL. Well, the included angle would be angle K. All right, angle K would be your answer. Okay, angle K. All right, now for letter B, they want to know the included angle for LJ and JK. Well, the included angle would be this angle here where the two sides meet, so the answer would be angle J. All right, angle J. Now, can I show you a faster way to do this without drawing a triangle? Which we're going to do in number 10. Look at this. JK, side JK and side KL have what letter in common? K and K. So the included angle is K. Side LJ and side JK have what angle or what letter in common? J and J. So the included angle would be angle J. So applying that quick shortcut, now let's take a look at number 10. Okay, in triangle QRS, what is the included angle for QR and RS? Well, it'd be angle R is the included angle because they both share the letter R. What is the included angle for side SQ and QR? Well, they both share the letter Q, so the included angle is angle Q. Let's quickly check our work. Here's Q, R, S. Okay, side QR and RS, the included angle is R, and that's what we have right here. Side SQ, side QR, the included angle is Q, and that's what we have right here. Okay, very good. Moving on to number 11. Oh, a proof. Good. I love proofs. Here we go. All right, let's go ahead and get into this. Here's our top triangle right here. Split these two triangles up. Here's the bottom triangle right here. All right, let's quickly label these triangles. We have ABC and ADC. Okay, now it looks like they've given us they've already picked up the given. They've put it on the diagram for us. AB is congruent to CD, and AB right here is parallel to DC. Okay, they want us to prove these two triangles are congruent. Now let's go ahead and think this through, guys. We know for sure that we have angle A or side AB congruent to side DC. We know that, okay? And students, it would be really easy to state that. Now I'm just brainstorming, okay? It'd be really easy to state that AC is congruent to AC because they share it's the same side. They share a common side. So guys, the only thing we're missing is a common angle. This angle here congruent to this angle here. Okay? And if we have that, then we have what? Side angle side of one triangle congruent to side angle side of another triangle. And we can do that. Look, guys, this is why it's so important you learn your previous math. Look, we have a parallel line. How do I know they're parallel? It's given to me right here. We have a parallel line cut by we have two parallel lines cut by a what? Transversal. Let's move this out of the way for a second. Look at this, guys. This is so cool. Watch. Look at that. Parallel lines cut by a transversal. And what do we know about parallel lines cut by a transversal? We know their alternate interior angles are congruent. Let's put the picture back up here. Look at that. Booyah. Perfect. All right. So this angle here, we're going to call it angle 1. Is definitely congruent to this angle down here, angle 2. So I can state this angle here is congruent to this angle here. I can do it. So there's my brainstorming. I'm looking pretty good. Okay. And here we go. So here's my list of things I need to accomplish. Here's my list. I need to look at your picture over here, guys. I need to state that AB is congruent to DC. I need to state that AC is congruent to AC, And I need to state that angle 1 is congruent to angle 2. Once I state that, I'm good. Okay, so here we go. Statements, reasons. I have to write really small here, okay? All right, number 1. I'm going to start allowing you guys to do what I used to allow my old geometry classes to do, and that's to put a slash right here and then put the word given. Okay, you don't have to rewrite it. We know it's right up here. You can circle that and we're good to go. Okay, all right, moving on. Number 2, look what I just stated. I just stated that AB is congruent to CD in my given, so check that off. Put a check mark there. Now next, hey, I can definitely state that AC is congruent to AC, right? Sure, that's the reflexive properties, the same segment. So my reason would be reflexive. And then number 3, I can definitely, let's check that off. Now let's state that angle 1 is congruent to angle 2. How do I know that? How do I know that? Well, look, guys, we already stated the 2 lines are parallel in our given right here. We know that. So if the 2 lines are parallel, then we can definitely state that alternate interior angles are congruent. Booyah, we did it. All 3 things were checked off, okay? So triangle ABC is congruent to triangle CDA. Now let's check it and make sure. Always check it, okay? What's first here? Angle A. Here's triangle ABC, angle A. Next should be angle C, and it is. Good, angle C. Okay, next is angle B. And this angle here is formed by the 1 slash side, okay, and the non-congruent side. So here's the 1 slash side, and here's the non-congruent side that we haven't marked. That's D, so D comes next, that's right. And then C and A, so we're good. So what reason would I put here? Did we use side, 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 or side, angle, side? Which reason? Well, we used side, angle, side, okay? All right, very good. Moving on to number 16, another proof. All right, here we go. Yes, we are given enough information, so let's do a proof here, okay? The first thing I'm going to do is slide this over, or not, and I'm going to, let's see. I'm going to use side, angle, side here, okay? So with that in mind, let me quickly list out what I'm given here. You are given that what? PQ is congruent to SR, and you are given that PS is congruent to, you know what, I would like to, well, boy, I really wish I could use side, side, side on this one, but this is going to end up being the exact same proof that we just did over there a second ago. So, okay, well, PS is congruent to QR, and we also know that PS is parallel to QR. Okay, all of that is marked for us over here. So there's our given, and we're going to prove that triangle PQR is congruent to triangle RSP. Okay, this will be a little boring. It's the exact same proof we just did. We'll do it real quick here. So here's one triangle, here's the other triangle, and let's quickly label those. PSR, QPR, and we have 2 slashes, 2 slashes, 1 slash, 1 slash. And now we could very easily use side, 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 because we could easily claim that this side here is congruent to this side here because they both share the common side here. Okay, we could do that. But to be honest with you, the directions do say to use side, angle, side, so we're going to have to do that. Okay, so very quickly, I'm going to grab this, and I'm going to turn it, and I'm going to show you that once again we have, watch carefully please, parallel lines cut by transversal, so I can state this angle here is congruent to this angle here. Okay, there we go. All right, so with that in mind, now I'm going to grab this thing and flip it back up so we can see it a little better, okay? Hopefully the whole thing will turn, I hope. Yeah, it does. Okay, good. Now, what I'm showing you here is that this angle here, P, right here is congruent to angle R down here. So what I have is this angle here is congruent to this angle here. And that's not going to be, and my fault guys, that's not going to be side angle side, is it? Side angle side needs to be this angle right here. So hold on one second here. Okay students, I'm back. Sorry about that. I was a little puzzled there, but no, we're good. We can definitely state that this angle here is congruent to this angle here. We can do that because don't forget, we can also state that this side here is congruent to this side here. And once we do that, look what we have. We have side angle side congruent to, now look carefully, side angle side. Okay, there it is. So let's quickly list out what we have to state in our proof. Okay, we have to state in our proof that, I'm trying to get a little room here guys, hold on a second. We have to state this. We have to state that PS is congruent to QR. We have to state that PR, that would be the, okay, PS congruent to QR. And then we have to state that PR is congruent to PR. Okay. Then we're going to call this angle 1 and angle 2. We have to state that angle 1 is congruent to angle 2. Okay, there we go. Once we state those three things, we can then state the triangles are congruent. Now, I'm going to go ahead and slide this out of the way for right now to give us some room. Okay, and if we need it, we'll pull it back up. Okay, so here we go. Statements, reasons. Okay, number 1 is just our given. So there we go. Now, in our given, we've stated a lot of stuff here. Look what we stated. Right here in your given, we stated that PS is congruent to QR. So that's really written, just so you know, that's really written right down here. So we can check that off, okay? Checked off. Next, I can easily state that PR is congruent to PR because of the reflexive property. And then I can definitely state that angle 1 is congruent to angle 2. Because remember, I showed you parallel lines cut by transversal. We had what? Alternate interior angles are congruent. When you have parallel lines, well, Mr. Earhart, how do we know we have parallel lines? We already stated that right here. It was in our picture for us, okay? In our picture right here, they had a red arrow here and a red arrow here. So whenever two parallel lines are cut by a transversal, we can state that alternate interior angles are congruent. So we did state this in our proof. We did state this. We are home free. We can now state that triangle PQR is congruent to triangle RSP, and the reason would be side angle side. Now students, let's quickly check our work. Angle P came first, and here's PQR. So angle P is the side formed by 3 slashes and 1 slash. So what angle over here is formed by 3 slashes and 1 slash? Angle R. So angle R better come first, and it does. Next is angle Q. Angle Q is formed by the 1 slash and the 2 slash, okay? So what side over here is formed by the 1 slash and the 2 slash? Angle S, and it does come second. So we're good. Everything matches up, and we're moving on, all right? Okay, they want us to prove these two triangles are congruent by using the distance formula. Well, that's really easy. We're going to do this very quickly, okay? I'm going to go super fast, all right? Here's the distance of ED. The distance of ED would be, what do we have here? 3, 6, 3, 6, and this is 6, 6. So here we go. X minus X, 3 minus 6 squared plus Y minus Y. Oh my goodness, Mr. Earhart's just really going old, guys. There's no need to do that. When it's a perfectly horizontal line or a perfectly vertical line, you can just count over. So we start here. We have 1, 2, 3. You don't start where you put your pencil. Put your pencil here and go 1, 2, 3. So the length of this is 3, and the length of AB is 1, 2, 3. So far we have one side, put a slash here, one side congruent with another side, okay? So I'm going to put a 3 here, put a slash, put a 3 here, put a slash. Okay, now let's go on. Okay, this point here is 1, 1. Letter A and letter C is 2, 4. 2, 4. So the length of AC is x minus x, that's 1 minus 2 quantity squared, plus y minus y, 1 minus 4 quantity squared. We would get 1 squared is 1. C, 1 minus 4 is 3. 3 squared is 9. You get 10. So the length of AC is the square root of 10. All right. Now, it looks like to me probably side DF would be the same. So let's do DF next. We have 6, 6. And for F we have 5, 3. So that's the distance of DF. So DF equals x minus x, 6 minus 5, plus y minus y, 6 minus 3 squared. I better pause and come down here. Guys, you remember the distance formula? X minus x, quantity squared, plus y minus y, quantity squared. Okay? All right. So 6 minus 5 is 1, 1 squared is 1, 6 minus 3 is 3, 3 squared is 9, and we get square root of 10. All right? So there we go. Cruising right along. All right? And then lastly, the length of CB, we have point C is 2, 4, point B is 4, 1. So we're going to find the length of CB. And that would be x minus x, 2 minus 4, quantity squared, plus y minus y, 4 minus 1, quantity squared. So we would have negative 2 squared is 4, 3 squared is 9. I'm getting square root of 13. I hope that's correct. So square root of 13. Put 2 slashes here, 2 slashes here. And now let's quickly find the length of EF. EF is 3, 6. And 5, 3. And here we go. X minus x, that's 3 minus 5, quantity squared, plus 6 minus 3, quantity squared. So we would get 3 minus 5 is 2, 2 times 2 is 4, plus 9, 6 minus 3 is 3, 3 squared is 9, square root of 13. There we go. So, yes, we can put 3 slashes here, 3 slashes here. Yes, we can state these two triangles are congruent. By what reason? Side, side, side. 3 sides of one triangle are congruent to 3 sides of a second triangle, okay? All right, moving on to number 24. All right. A good thinking problem here, okay? First of all, we know that ABC is equilateral, okay? So let's mark that off. This big triangle here is equiangular. So what that means is this whole angle here is how much? 60. This whole angle here is how much? 60. And this whole angle here is how much? 60. Now, because notice that all of these segments are A, okay? We're taking this triangle here, guys, and we're dividing it into 4 equal parts. Not the segments. This angle here is A. This angle here is A, this angle here is A, this angle here is A. They're all called A, so they all have the same measurement. So if I take 60, this whole angle and divide it up into 4 equal angles, I would get 15. So this little angle here is 15, this little angle here is 15, this little angle is 15, this little angle is 15. Now they want us to find the measure of angle B, this angle right here. Okay? Now watch this carefully, students, please. See this triangle right here? I'm going to pull that off to the side, okay? Now, we already stated this angle here is 15 degrees. And we already stated this angle, well, we don't know any other angles, but look, this line here cuts the angle right in half. It has to. It cuts the triangle right in half. It has to, because all of these angles here are the same, so we knew we divided it up into 4 equal parts. So this is a right angle here. This has to be 90. So now that allows us to find angle B very easily, okay? 15 plus 90 is 105. So angle B has to be 75 degrees, because 75 plus 105 is 180, okay? All right, last problem, and we're finally done. This is going to be really, really interesting, so watch carefully. Please watch what I do here, students. Very important. We can do this. It's a very tough problem. Watch carefully, okay? Okay, they give to us m plus n plus p minus q plus r plus s equals blank. All right, now watch carefully what I do. See angle m? Well, remember, we learned that an exterior angle is equal to the sum of the two remote interior angles. So m equals, for m, I can put r plus s, because m equals r plus s, okay? Now, n equals q plus s. N, exterior angle n, equals the sum of the two remote interior angles. So don't forget that, okay? It's the theorem that we learned. So n equals q plus s. So for n right here, bring down your plus sign. I can put q plus s. Bring down your plus sign. Next is p. Well, p equals q plus r. Here's p. Exterior angle. Here's your two remote interior angles. So p equals q plus r. So for p, I'm going to put q plus r. Then bring down. Now this minus sign here gets distributed all the way through the entire parentheses, okay? So pretend there's a negative 1 there if you want to, okay? So I'm going to take a negative sign and multiply through. A negative times a positive is a negative q. A negative times a positive r is a negative r. And a negative times a positive s is a negative s. Now let's see what we have here. We have r. Okay, this r here would cancel out with this r here. This positive s here would cancel out with this negative s here. This positive q here would cancel out with this negative q here. So we're left with a positive q and a positive s and a positive r. That's what we're left with. Well, that's the inside of the triangle, guys. Q, s, r. That's what we're left with. So we took this whole original expression. We made some equivalent substitutions. Then we simplified down to this. So we know the answer has to be 180, because the sum of the three angles inside of a triangle always equal 180. So the sum of all of this up here is 180 degrees. Okay? All right, pretty cool problem. All right, if you guys have any questions, don't hesitate to call or email. I hope this video has been a help to you.